pre-calc. We're going to look at our lesson 1.5 on combined transformations or multiple transformations. So what we're going to do is we're going to put more than one of these transformations together, a reflection, translation, or a stretch or a shrink. So just to kind of review first, reflecting across the x-axis, we negate the function in front. If we want to flip it across the y-axis, we negate the function inside. So kind of just a little warm up here to make sure we understand what's going on here. Also look at some of these other pieces as well too. So we'll get to these here just in a second, but just also make sure we understand in the translations piece, I always like to think about here, if it's inside the parentheses, we're affecting the x value. We're moving left or right. And again, if it's inside parentheses, I like to think opposite. So if you see a minus c inside the parentheses, it's actually moving it to the right c units, and vice versa for the plus. That'd be moving it to the left c units. If it's outside the parentheses, then that's going to be a vertical translation, moving it up or down. And that one does it as is because it's not inside the parentheses. So, think of this as moving in up c units, and this would be down c units. In the stretches and the shrinks, let's kind of take a look at that piece. Let's see if I can move that there. I guess I'm going to have to shrink that a little bit. So I can move that over. Ooh, whoa. And if we're looking at the stretches or shrinks, again, if it's inside the parentheses, and if we're dividing, well, then it's a stretch. It's a horizontal stretch. So inside the parentheses, again, inside the parentheses by the x means it's affecting in the x direction, so it's affecting it left, right. So I always like to think about when we're dividing, and usually that's the number less than overall. For dividing, that's when we have a c value, that's greater than 1 here, so it'd be a fraction. This piece, that's a stretch. But again, I'm going to show you a little easier way to remember that I always like to think if we're dividing, we're stretching. If we're multiplying inside, we're shrinking. And then with the vertical stretches, again, the number outside is not inside the parentheses. It's not by the x, so that affects the y value. So it does it as is. If it's a number bigger than 1, we stretch it vertically. If it's a number less than 1, we squish it. So just to kind of look at some examples here. If I'm looking at this first problem, I see that we're inside the parentheses here. We're inside the parentheses by the x. So I know something's happening horizontally. Something is happening left to right. So if it's inside parentheses, I like to think opposite. So if I'm multiplying by a number, I'm really making it smaller. So this is a horizontal shrink. And then we got to do is actually kind of take the reciprocal of that. And so the scale factor is 1/3. So it's shrinking to 1/3 its size horizontally. And number 2, we notice there is no parentheses. It's outside the parentheses. In fact, if you really wanted to, you can kind of put it like that and say that there's the x squared. The 3 is outside. So that's affecting it vertically. So that's a vertical, affecting vertically. And if it's outside the parentheses, it does it as is. You don't have to think opposite. So this is a vertical stretch. And then that scale factor would be 3. So again, we got a number inside the parentheses, so I know what's affecting it horizontally. And I can think of that 0.5, if I really wanted to, I could kind of think of this as just a 1/2. Okay. So, when I think of that inside the parentheses, I got to think opposite or reciprocal inside there. If it's a half, I'm not getting, that's a smaller number, but think opposite, so it's actually getting bigger. It's actually stretching because it's inside the parentheses. You think opposite. So it's a horizontal stretch. Okay? And that scale factor, again, because it's inside, we think opposite, so we got to kind of reciprocate that. Think of the opposite of 1/2. So that'd be a scale factor of 2. This one is outside the parentheses. Again, if there was a little parenthesis, you could think of it there. So again, this is going to be a vertical. It's going to affect it vertically. And when it's outside the parentheses, it does it as is. So you can think of 0.5 as 1/2. So this is actually a vertical shrink. And again, as is, because it's not inside parentheses, so it's a scale factor of 1/2. So it's shrinking it by 1/2. All right, and then we get a little more complicated. We're going to put a bunch of them together, and we'll practice a couple more over here, and then obviously in the next page here as well, too. But really what I would probably do with this problem is kind of adjust it so I can have these kind of concepts up here to be able to think about. And I'll show you a little easier way here in just a second, too. So when I do this first, usually I like to have that x first. So I'm going to factor a negative out. Or first of all, maybe just rearrange it. Just go negative x plus 5 squared. And then maybe I could take a negative out. And then I have x minus 5 squared. Because then I can kind of see what's happening with this graph. Originally I thought this one has a parent graph of y equals x squared. You can tell that because I got the squared there. But really what I have here is I've got a little negative out front. Okay, so that's kind of this idea, and it's inside the parentheses, so it's like this situation. So I know it's a flip across the y-axis. Okay, so this is a flip across the y-axis. And then I know here, again, this is inside the parentheses by the x, so I know it's affecting it horizontally. Okay, so I know something's happening horizontally to this. And I'm getting something subtracted. It's inside the parentheses, so we think opposite. So instead of subtracting 5, I'm going to add 5. So when I add 5, I move to the right. So this is moving horizontally to the right 5 units. So that's what you can kind of put on the blank here. Now the question is, which one do we talk about first? And kind of a way to remember that is kind of like when you get up in the morning. This is what I talked about way back in advanced algebra. Is that when you get up in the morning, you got an alarm that goes off. So you're in your bed, your alarm goes off. The first thing you do is you flip over and get ready to turn that alarm off. All right. Excuse me. So once you turn that alarm off, you then stretch. You get yourself and stretch out. Stretch out after sleeping all night, and then you walk out of bed. So you make that move. So flip. It's kind of imagine that your head alarm goes off. You flip over, turn the alarm off. You stretch, and then you walk out of bed. So that's going to help you remember that what you do is you do your reflections first, and then you do your stretches or your shrinks, and then you do your translations. Okay. So some teachers teach it just to say, hey, just make sure you remember RST. And if that helps for you too, that's great. I like to give you a little visual. So let's take a look. Let's look at another problem here. It's an example of combining transformations in order. So sometimes they'll just simply tell you what to do. Okay? And you just got to simply follow those directions. So what we're going to try to do is we're going to try to take this original graph, the y equals x squared, so that's our normal little parabola. Okay? And we're going to take the following transformations to that. Okay? So if I look at this first one, this is just telling us what to do first. So we're going to do a horizontal shift of 5 units to the left. So again, we start thinking about horizontal. Okay? Now it's got to happen by the x. Okay? So it's got to be in by the x. And if if I want it to go to the left, shifting left to the right, if it's inside that, I got to think opposite. So this has got to go plus 5 squared. So that represents that piece. Now what I want to do then is take that graph after moving it to the left 5 is give it a vertical stretch by a factor of 3. Well, a vertical stretch would then be out front. It would be inside the parentheses. And that stretching is that multiplying is a factor of 3, so it's 3 times stretch. So I get a 3 out front. And the last one would be a vertical translation, if it being moving up 5. So again, if it's a vertical, it's not inside the parentheses. And I'm going to just move it up 5. Or up 4, sorry. It should be that. So kind of if we look at our graph, we're starting back here at 0, 0. All right. I can think about this. I need to do a horizontal shift of 5 units to the left. So I'll go over here. I'm going to have a vertical stretch by a factor of 3. So normally on the graph up here, what you'd have is you'd have it at 0, 0, and then 1, 1, negative 1, 1 as you kind of come through. So if this is a vertical stretch of 3, this distance 1 is now going to be 3 times. So, the graph, originally is like, right here is the original graph. At 1, 1, then it'd be like at 2, 4. Then the graph gets moved to the left 5. So now it's over here. It's still got the same pieces here. So 2, 4. So now it's kind of like right here. And then we got a vertical stretch by a factor of 3, so I'm stretching this 3 times. So now it's still right here, but instead of going to 1, 1, it'll stretch it 3 times. So now it'll go to 1, 3. So now it's this. And I'm going to move it up 4 units. So then 1, 2, 3, 4. So it's really right here. Now instead of going to 1, 1, I'm going to go over 1 and then up 3. And that's kind of where that graph would end up. Okay. So again, like I talked about over here, again, when we do a graph with more than one transformation, these are the rules, unless it's stated for you to do differently. Is that the RST piece, are again that flip, stretch, and then walk out of bed. Okay. So here, what I want to do is kind of give you a little bit of a synopsis here that kind of gives you kind of any general function. When we start dealing with some of the other ones that we'll have here in the future. All right, so let me just kind of use a little different color here, and talk to you a little bit about some problems here. What I like to look at is some general equation like y equals a times b times x minus c plus d. And you can use different letters in here, and that's perfectly fine. Okay. So And you can change this. We can put a squared up here, a cubed up there. We can put a sign out front. Some lots of different things. But this is one that kind of gives you a general idea of what should be happening here. And just some kind of quick notes. Okay, what this a value does. Okay, so what that a value does, that's our vertical scale change. Okay, our stretch and our squishing. Again, it's outside the parentheses, so we do as is. If that was say a 5, we'd be vertically stretching it 5 times. If it was a 1/3, we'd be vertically squishing it by 1/3. Okay. This over here, the D, again, that's outside the parentheses as well too, so it's affecting the Y value, so it's affecting something vertically. And this is just a vertical shift or translation. And again, we do as is because it's not inside the parentheses. Okay, so if that was a 5, it would move it up 5. So this moves it up or down. If it was a -3, we move it down 3. Again, do as is because it's not inside the parentheses. And when it's not inside the parentheses by the X, it affects the Y value, affects the vertical positioning. Okay. Let's look at the ones that are inside the parentheses. Okay. And let's look at this B value. Okay. This B value, okay, is where we're going to have, again, it's inside the parentheses by the X, so it's going to affect it horizontally. Okay. So this is a horizontal scale change. But again, because it's inside the parentheses, I want you to think opposite. So if that was a 3, you think 3 is a number above 1, we'd be making things bigger. But again, think opposite. This would be if that number was 3, that'd be a horizontal squish by 1/3. So we think of that reciprocal. This number right here, the C value, again, that's inside the parentheses by the X, that's going to be our horizontal shift. And again, we're going to think, when we horizontally shift, that's a translation. We're thinking either right or left. And again, what I want you to do is think opposite because it's inside the parentheses. Okay, so if this was a -5, we'd be thinking opposite, so it'd be actually moving it to the right 5. If this was a +7, we'd be thinking, opposite, so I got to go to the left 7. Hopefully that helps a little bit and clarify some things as we kind of move forward as kind of a little shortcut. So let's get a little practice here. All right. So this first one here says first describe, then graph the transformation. So again, remember now when we describe these transformations, we're going to talk about if there's any flipping first. And there certainly is. If I look right here, there's a little negative out front. So that negative out front tells me it's going to flip upside down. It's going to flip over the x-axis. Okay. So then I'm going to look at if there's any stretching then next. Okay, so this is the first thing. First thing it does is it flips over the x-axis. Well, here, if I look at the 3 here, that'll tell me that it's outside the parentheses. Okay, so it's going to affect it vertically. And when it's outside the parentheses, we think as is. So this is a vertical stretch of factor of 3. I don't see any other numbers inside here being multiplied on the inside of the parentheses, so there's no horizontal stretch or shrink. All right. But I do see some other numbers here out, that are being added to the x, and outside the parentheses being subtracted. All right. So just as I kind of keep reading to the right here and taking care of each of these numbers, I notice there's a +2 inside the parentheses by the x. So again, by the x is a horizontal. There is a horizontal shift. And again, it's inside the parentheses, so we think opposite. So a horizontal shift, that would be, you'd say, to the left 2. And the last piece is outside the parentheses, so that's going to talk about a vertical movement. And again, it's outside the parentheses being added or subtracted, so that's a vertical shift. And when it's outside the parentheses, you think as is. So this would be down 1. Okay. And then knowing that this is a cubic, that that the original cubic would be coming in, roughly like this. Okay. So what I got to do is I got to flip this over the x-axis, and then stretch it 3 times, and then move it left 2 and down 1. So in doing that, take the first graph here, and again, I know some points on here are 1, 1, 0, 0, and -1, -1. Okay, so I'm going to flip that over the x-axis. Okay. And just go with the color. So now it'll be here, here, and here. So come in like this. Then I got to take this as a vertical stretch by a factor of 3. So now instead of coming through here at -1, 1, it's going to stretch up, so we should be at -1, 3. Okay. So -1, 3, and same thing down here. This would be at 1, -3. So it's coming in and being a little tighter. And I'm going to move it to the left 2 and down 1. So I'm just going to take each of these points and move it to the left 2 and down 1. Oops. So left 2, down 1. Left 2, down 1. And then left 2, down 1. So my graph should be right about there. And the green one's the final one. Let's just look at another one. Okay. Our parent graph here, if I look at this, is just the absolute value function. So I know that's going to make that v. So our original one here is at 0, 0. Then has it at 1, 1. Would actually then be at 2, 2, et cetera, et cetera. So -1, 1. When I put -2 in, I get 2 out. So again, that would be my absolute value function. All right. And let's look at the transformation here. Only one thing is happening here. There's just a 2 out front. So it's not inside the parentheses. So this is some type of a vertical change. It's being multiplied. So it's a vertical stretch. And because it's outside, we don't have to think opposite. So it's got a vertical stretch with a factor of 2. So I'm pulling everything up this way 2 times. So now instead of this graph being at 1, 1, if I stretch it twice as much, now it'll just be at 1, 2. 0, 0 would stay the same. 1, 2 would be twice as much, and we'd have a graph there. 3 points is usually enough. The graph. All right, we'll try another one here. And if I look at this function, I see a squared. So I know my parent function is y equals x squared. It's that original parabola, that 0, 0, 1, 1, 2, 4, if you want to go any more. Okay, so it'd be a negative 1, 1, negative 2, 4. Have a parabola like that. That'd be our original one. Let's look at what happened here. And this is one we might have to do a little bit of factoring with here. So what I might do here is just make this y equals, and I might factor a 2 out of that. Okay, probably didn't need that extra parentheses there. Well, maybe I do fact because it's inside there. So I'm going to factor that out. So I got 2 times x plus 2 because that squared there. I can't pull that out of the parentheses because of the squared because this all still is squared. Okay. So that tells me a little something about that too because it's still inside the parentheses. That when I look at this, that's inside the parentheses, so it's going to affect it horizontally. Because inside the parentheses we think opposite, that's a bigger number than what we're usually multiplying, so we gotta think we're gonna actually opposite of multiplying or making it bigger would be to shrink it. This is actually a horizontal shrink, and then the opposite of that 2 would be a half, so that's got a horizontal shrink with a factor of 1/2. The piece inside here is inside the parentheses being added. So again, if it's inside the parentheses by the x, okay, if it's inside the parentheses by the x, it's a horizontal effect. This is horizontal, and because it's being added, it's a shift. And again, inside the parentheses, we think opposite. So this would be a horizontal shift to the left 2. So I guess you could have put all that stuff down here in this blank here. That's kind of what happened. So again, what I'm going to do is, again, I'm going to do the stretching or the shrinking before I, walk out of bed here, or do the translation. There is no flipping because I don't see any negatives. So I'm going to horizontally shrink this by a factor of 1/2. Okay, so if I look here, this point here that's at 1, 1 now would be at 1/2, 1. The same thing on this side, so it's kind of shrinking it in a little bit. If I kind of blow it up a little, maybe we can see. And this one here, instead of being out to 2, is now at 1. This one's at 1, so I'm just shrinking it horizontally. Vertically, I'm not doing anything. It's still got the same height. Okay. And then I just got to move it to the left 2. Okay. So just move this to the left 2, so 1, 2. And then all these points have moved, so we just have it to the 1/2 and 1/2 there. Move this one to the 2 would be right there. Move this one to the 2 would be right here. So there would be my new moved, transformed graph. Okay, well, what I want you to do is down here at the bottom, these are way back from our first lesson, and what I want to do is have you pause the video, work through these 4 problems, and see if you can visualize and just kind of tell me how this graph has been moved. And after that, then find the range. So we'll have you pause the video here, and give it a try, and we'll be right back with you. All right, and hopefully this is what you got for your answer. And the first one here was just a horizontal shift to the left of the square root function. So we've got our range down here. Pause this video if you need to just take some time to look at this to fill out your sheet. But again, this is then a horizontal shift to the left 3 and down 5. There's our range. This one's a parabola. All right. If I start here, that's a negative out front, so that flips it over the x-axis. The 5, it's not inside any parentheses with the x, it's out front of it. So that's a vertical stretch of 5 times. And again, this is not inside parentheses, so that's a vertical shift, and as is, because it's not inside parentheses, so down 4. So that's what the graph looks like there, and the range. And this one's just in absolute value. It's inside the absolute value. So we think opposite. And it's also inside by the x, so it's a horizontal shift. So think opposite, just go to the left 7. And there'd be our range. So there we go. There's lesson 1.5. We're going to get lots of practice this week, doing some group work, some individual work. But you should be good to go to work on the worksheets. And I wish you good skill.